Hi, so me, Firdaus and Azim are gonna explain about outflow meter test. So right now, we're gonna explain about the procedure and the apparatus for outflow meter test. So for the apparatus, first we need the outflow meter apparatus. Next, the loading, and then identify the surface that we want to use and clean it. And then the last one, stopwatch.
First, we need to make sure the pavement surface is clean and dry. Next, place the outflow meter on the top of the pavement surface carefully. Then, put the loadings on top of the outflow meter. This is done to ensure the apparatus stays stable and does not move during the test. After that, fill the outflow meter with the tap water until the top level. Once it is fully filled, the test is ready to begin. Now, when performing the outflow meter test, we will open the tap. As soon as we open the tap, the water level inside the apparatus will begin to decrease. At the same time, we start the stopwatch. For this test, there are two timing points recorded. The first timing is taken at the 400 ml mark, and the second timing is taken at the 100 ml mark. For this section, I will explain the results of surface drainage performance for fine, medium and coarse surfaces. Starting with the fine surface, based on the table, the flow rate values recorded give an average of 44.22 mm per second. This indicates that the surface is dense and less permeable, which slows down the water movement. In other words, the fine surface shows a weak drainage performance, and it can potentially cause water to remain on the road surface. Next, for medium surface, the flow rates are significantly higher with an average of 552.0 mm per second. This suggests that the surface texture is well balanced, allowing water to drain smoothly without being too tight or too open. So overall, the medium surface provides the best drainage performance among the three surfaces. For the coarse surface, based on the values in the table, the flow rates gives an average of 186.71 mm per second. This surface is more open compared to fine surface, so the drainage is better, but it still does not perform as well as the medium surface. Lastly, we compare these results with JKR standards. We can see that each surface falls within its standard range, but the medium surface clearly performs the best and meets the standard effectively. So in conclusion, based on the table and standard comparison, the medium surface is the most suitable surface in terms of drainage performance.
The apparatus of the study include Ottawa sand, sand spreading tool, brush cone, a ruler, measuring cylinder, soft brush and wire brush, and also pavement surface. First, the pavement surface was cleaned by a steel wire brush to remove dirt and loose materials, followed by cleaning with a soft brittle brush to ensure the surface was clean and dry. By using measuring cylinder, we take 10 ml of Ottawa sand. The sand is poured through the brush cone to ensure the sand falls smoothly without any spilling. The sand was then carefully poured directly into the center of the pavement surface. Next, spread evenly in a circular motion using the sand spreading tool until the surface voids were fully filled. The diameter of the sand patch is measured using a ruler. 3 readings are taken to determine the average diameter. For this study, we choose 3 different locations: fine surface, medium coarse, and coarse surface. calculate the texture depth, we need to find the area by using the average diameter. Then, we divide the volume by the area, resulting in the texture depth in milliliter. So based on the result, the fine surface recorded the largest average diameter, 137.7 milliliter. This results in the texture depth of 0.67 milliliter. According to JKR standard, the average texture depth for road surface should be at least 0.75 milliliter. So this surface is considered smooth and below the acceptable limit. While for medium coarse, the texture depth found is 1.10 milliliter. So this exceeds the JKR minimum requirement and indicates a moderately rough surface that meets the standard. Finally, the coarse surface recorded the smallest average diameter of 97.7 milliliter and the highest texture depth of 1.33 milliliter. So this indicates a rough surface with greater potential for drainage and skid resistance. In conclusion, the result shows that surface texture depth increases from fine surface to coarse surface with range from 0.67 mm to 1.33 mm. This demonstrates that rougher pavement surface provide better skid resistant potential and surface drainage, particularly under wet condition, supporting the project's objective of understanding the relationship between pavement characteristic and road safety.
First, the apparatus is stabilized by adjusting the leveling knob until the bubble in the spirit level is centered. Next, the test surface is cleaned using a brush to remove dust and loose particles. After that, ensure the pendulum arm is in the correct position and not positioned like this. Adjust the height of the pendulum arm by turning the lifting screw and the knob behind the scale to obtain the optimum position. This is the condition after the apparatus has been properly calibrated. The rubber slider will make contact with the surface when the pendulum arm swings. Clean the surface by using the brush. After that, the surface is wetted using water according to the surface condition. The rubber slider is also wetted using water. The apparatus is checked again before conducting the test on the surface. Ensure that the contact between the rubber slider and the surface both before and after the swing is within the acceptable range.
The skid resistance test was done for both conditions of a dry surface and wet surface. The average of the values was calculated for analysis. On the location of fine aggregate pavement, an average of 64 was determined for dry surface and 47.67 for wet surface. In the case of medium aggregate pavement, the dry surface had a value of 94 and 71 for the wet surface, whereas the coarse aggregate pavement had 102.67 and 77.33 for cases of dry surface and wet surface respectively, based on the standard specification for roadworks in Malaysia set by JKR. Only the coarse aggregate pavement met the recommended value. Medium aggregate pavement overperformed the recommended value, proving a high skid resistance, while fine aggregate surface slightly underperformed the recommended value for the dry surface, but overperformed the recommended value for the wet surface.